Welcome back. Topic 6, square roots today. The first problem that we are going to do is a simplification. Now we know that square root of 3 is the very basic form. Square root of 27 is square root of 3 square times 3. And square root of 75 is 3 times 25, which is 3 times 5 square. So let's write it in that fashion. It is better to put the bar on top. That way you know how much of the how many numbers are covered by this square root. Equals square root of 3. Now from here, 3 square from inside, if I take it outside the square root, I will get just 3. And inside this other 3 will remain. Plus. Again here 5 square, if I take it out of the square root, I'll just get 5. And then the 3 inside will remain. So now you can see that square root of 3 minus 3 square root of 3 is just minus 2 square root of 3, and then plus 5 square root of 3 is total 3 square root of 3. And then we get, squaring this, we should get 3 square times square root of 3 square is just 3. And this is, of course, 9 times 3 or 27. And this is your answer. Problem 6.2. We have to find x from this equation. X square minus 15 equals 7. Now, one way to do it is just square both sides. So if we square both sides, we get x square minus 15 equals 7 square is 49. Or take this 15 to the other side. X square equals 49 plus 15 equals 64. Now, remember that when you take square root of 64, there can be two such solutions, or x square equals 64. Let's write that step. Or x equals 8, which is plus 8, or minus 8. Why minus 8? Because minus 8 times minus 8, which is minus 8 whole square, it also gives 64. So make sure that you use both roots. It is simply written as plus or minus 8 to represent that both solutions are possible. And that is your answer. Problem 6.3. Now this is an interesting problem. It is asking for three numbers, square root of minus 1000, cube root of minus 1000, and then finally fourth root of minus 1000. Of these three numbers, we have to find which number is or are not defined. Now, a square root is defined only if the number inside or the quantity inside is positive, 0 or positive. So we say that for the first one, we say that since minus 1000 is negative, minus 1000 square root of that is not defined. But that is not true also for cube root of minus 1000. Because cube root of 1000, if you multiply minus 10 three times, you do not minus 1000 cube root can be written as cube root of minus 10 cube. See, if a negative quantity is multiplied three times by itself, then you get a negative also. So that's why minus 10 cube will give you minus 1000. And simply, if you take a cube root of that, that gives you minus 10. So this is a defined quantity. This is a defined number. So minus 10 cube is defined. And finally, the same fate of minus 10 square happens to the fourth root of minus 1000. Why? Because fourth root is square root of a square root. So you can write square root of a square root inside, and the inside is 1000. And we know that if the inside is not defined, then the number is not defined. So of these three, only the middle one is defined, the remaining two are not defined. So any even root, fourth root or sixth root or 10th root, whatever be that, you cannot define with a negative quantity inside.